Okay, so back last year in geometry, you guys did some proofs. And yes, you can all sign grown, but the proofs were basically if on this side of the planet, I give you three sides, I say, hey, you guys in your different homes and somebody else in China across the country, across the world, you guys go ahead and draw a triangle that has sides that are 3, 4, and 5. And the truth is, if you have the same side, you're going to end up drawing the same exact triangle as anyone else in the whole entire world who draws a triangle with those dimensions, because it's a proof that if you start with those three sides, you're going to end up drawing the same exact triangle. Now, on the other hand, if you draw a triangle with the same angles, well, that doesn't guarantee that you're going to have the same triangle as someone else. Okay, it'll be proportional, but doesn't mean it's going to be the same. So you guys used multiple proofs last year when you were doing triangle proofs. And those were to show, hey, if I have this side angle side as somebody else, we will be drawing the same triangle. Okay, and so the one that you couldn't use was angle side. And it's not just because it's a bad word, it has to do with it doesn't actually prove anything. And so we're going to investigate that today. And that's called the ambiguous case. It's not a proof. It's something that says if you have the same angle side as somebody else, you may or may not actually have the same triangle. What do you mean? Well, let me show you. If you start with an angle that's going to say be 20 degrees, okay? And if perchance the side across from it, okay, side A perhaps is actually say 8, and we could do inches, and say that the side over here is going to be, say, 10 inches. Okay. The truth is, the way that this is situated, sometimes they're dumb and they give you an impossible triangle. Okay. So instead of giving you a 20-degree triangle that has a side of 8 and a side of 10, they'll be like, try this one. And they'll say, well, if this is 20 degrees and this is, say, 10 inches, why don't you try to make a triangle that just has 1 inch on this side? Well, the truth is that is not going to form a triangle because that next side is not going to be long enough. So within the angle side situation in this ambiguous case, they think they're cool and they sometimes give you triangles that aren't actually connectable. Okay. And so when you go to solve them, you're going to get an error. And so I don't want you to lose your mind if they give you a triangle where you start drawing it, you try solving it, and it actually doesn't form a triangle and you get an error. We'll do a question like that. And that's shown in this first picture. Okay. The second thing they could give you would be that if you're drawing an angle side, you can draw a triangle a certain way. And the truth is that it is possible that you could draw a second triangle with those exact same dimensions. What do you mean, woman? Well, look, say that I've got the dimensions 20 degrees. And then I've got this that's 10 inches. Well, I drew this one with 8 inches here, but what if instead of drawing this kind of openly, I draw it tucked inside of this dimension to be 8 inches? Do you see how both of those triangles have the exact same dimensions, but they're not the exact same triangle, are they? So an ambiguous case, like just ambiguous directions, like go over to the place with the people, you could interpret it multiple ways. Well, same with an angle side. It's possible, number one, that you can't draw a triangle. It's possible, number two, that there's two ways to draw the exact same information. So with the given data, you could have two different triangles with the exact same given situation. And so that's kind of what we're going to investigate today is, can you even draw a triangle? Is there a single triangle that could be drawn, or there are multiple two triangles that could be drawn with those given informational pieces? And so here they try to show you that information here. So let's look. We've got in this chart, maybe there's not even a triangle. You're like, well, that's lame. I know it makes an easy question, but maybe there's no triangle. Okay. The second option would be maybe there's just one triangle you can draw. Okay. And then on the third situation, maybe there are two different triangles that you could draw, one with its open and one if you bring in the same side to make it smaller. So we'll talk about those three things. And then there's a couple other things on the right, and we'll speak of those in a skosh. Okay, so let's start walking into this. So if you look at this first question, I noticed that there are two sides they give us, okay? And they give us the side A, and they give us the side B, and they give us an angle. Now you're like, stop thinking so terrible. How do you know that it spells angle side side instead of side angle side? And I think the big thing that you should know is that if it's going to spell angle side side, you have a pairing. Well, what do you mean? Okay. Angle side side has an angle and its related side across from it, as well as another side. Okay. Whereas if you had side angle side, look at the picture I'm going to draw here. If you know side angle side, you know a side, maybe it's B, maybe you know side C, and then you know an angle A. Okay, notice you don't have an angle with its related side across from it. You simply have a side, and an angle that happens to be between them. So if you've got angle side, side, you're going to have an angle and its related piece across from it. So let's keep trucking here. So what I have found, if you've got angle side, side, is draw it with the angle in your left hand. Okay, if you hold up your hands in front of your face, you will see, put the angle in your left hand. Okay, so angle A, label it, is 28 degrees. Okay, and the side they give you is side A, who is across from it. So draw it across from angle A. So this is side A, and label it is 50. And then they give you another side. Put that between the angle and the side they give you. Okay, so they give you side B, and they give you the side B is 20. So that means angle A is across from side A, and then the side up here, the angle A would be above it, and then side A will be across from that. So with the ambiguous case, you will have a pairing. Okay, so go ahead and use the law of signs to solve it. Okay, I know angle A, and I know side A across from her. So let's start the relationship, okay? And so if we do sine, I don't know why I'm using a highlighter, sine of 28 degrees goes with 50. Okay, that's with side A and angle A. Good morning, kitty. And then that equals angle B over side B, which is 20. And if we cross multiply and solve this, you don't have to show every step. You do need to show the setup. You're going to do 20 sine 28 equals 50 sine B. Divide both sides by 50 and then take inverse sine. The measure of angle B is going to equal approximately 10.82 degrees. Okay, so here we go. And we were given angle A is equal to 28 degrees. And then if you subtract those two from 180, you will get angle C is equal to, I don't know why I have two angle A's. Let's erase that and fix it. Okay, obviously this would be C. Okay, so let's make this C. And side C across from it. So angle C, if you do 180, if this angle here, angle B is 10.82 degrees, 180 minus 28, and 10.82 will give us 162.82. Okay, and then we have to find the bottom of the triangle, so side C. So you do the sine of angle C, which is 162.82 over side C, should equal sine of 28 over 50. Okay, that's talking about side A. So if you cross multiply and solve, you get the measure of side C to be equal to side C would equal 31.45 in units. Okay, try not to round till the very end. So if you're doing these different decimals, make sure you carry them and grab them in your calculator so you don't have to round off until your final answer. So we've got A, B, and C. They gave us side A and they gave us side B, but so side C would be 31.45. Now the story is this. I noticed we had angle side side. So the question is there a secondary triangle that you could form with this data? Okay, and how you figure this out would be this. If you were to perhaps position side A at a closer distance to B, okay? First of all, I want you to look at this. Side A, or side B perhaps, is going to be 20, okay? Side A is 50. So if I draw this to scale, side A is going to be very long off in that direction. So could I really bring it underneath here to fit underneath a 20-degree length or 20 unit length? And the answer is, of course not. Okay. If you go to the circus and you try to bring home an elephant, it can't fit, inside and outside. It's got to stay outside. So if you truly drew this to scale, you would notice this side right here was 20 and the side over here is be way like 50. Okay. And so with a 28-degree angle, there's no way you could bring this side that's 50 and bring it down here. It would like cause that 20-degree angle to open up quite a bit further. And so the answer is we're not going to be able to bring that triangle in as a more narrow triangle. It has to stay out as 50. Now, if you can't quite see what I'm talking about with that, what I would suggest is that we do the math of it. Okay. So let's think about, we're talking about this picture right here. Like, can you have the side A swing in to make a more narrow triangle? And so let's talk about this. If you would swing it in, it would still have to be 50 units long. And so that means this side and this side would have to be congruent. Okay. Now it's given that the first angle is 28 degrees. It's given this side is 20. If you just kind of look at this triangle here on the right, it looks like an isosceles triangle. If two sides are the same, the two base angles must be equivalent as well. And so if this base angle on the right is 10.82 in an isosceles triangle, this angle would have to also be 10.82. And so if you wanted to find what a narrow triangle would look like here on the left, given the angle of 28 degrees, the side of 20, and a 50 that's swung in instead of out, in order to find this angle over here, you would have to do the supplement to 10.81. Okay, so you'd have to say, okay, if this triangle here is an isosceles triangle, these two base angles are 10.82. This angle here would be the supplement. And so you'd have to find the measure of angle B2. Okay. If angle A is still 28 degrees, angle B2, okay, and a second option for swinging in that side to make it more narrow, you would take the supplement 180 minus B1. And so you'd go 180 minus B1, which is 10.82, and you would get an answer of 169 angle B2 equals 169.18. Okay, so here lies the problem. Okay, if you swing it out, we already solved that triangle, but if you try to swing it in to make a more narrow triangle with those given dimensions, the problem is you'd have to find out what angle C number 2 would be. So at the top of this smaller triangle. So that means given A and B are those values, angle C number 2 would have to be 180 minus both of those. And so if you do 180 minus 28 and 169.18, you get the measure of angle C number 2, that more narrow triangle, to be negative 17.18. So the answer is that's not possible. So not only if this is 50, it wouldn't fit to go inside for a more narrow triangle, but also if you do the math of the angles of a more narrow triangle, it doesn't actually work. So there really is only one triangle that you can draw with those given dimensions from angle sides perspective. So sometimes there's no triangle formed. Sometimes you can form two different triangles, a wider and a more narrow, if you take that second side and have it wide or bring it narrowly. And you always, always, always say, take 180 minus this angle here to see if you're going to be able to form a second triangle. And so we'll talk about this a couple more times. The next question, okay, I noticed they gave us two sides and an angle. And so we look at this and say, okay, and there's a pairing. I see they gave us side C and angle C. Okay, and so we're going to draw it in our left hand. So angle C is 105 degrees. Now, we didn't talk about if there are given angles obtuse, but look up here. If it is obtuse, there's really only one potential triangle that you could form here, okay, if there is a triangle. So let's see if we get an error or if we actually get that to be formed. So there is not a wide and a narrow way to form it if you have an obtuse angle they give you. They give us angle C is 105. So let's just see, can we solve the triangle they gave us? So angle C is 105. Side C is equal to 10. They gave us side B is 6. So let's put be between the two things that they gave us. So B is equal to 6. Means this is angle B, and this has to be angle A and side A below here. So let's use the law of sines to solve this triangle. So using the giving pairing that they gave us, so the sine of 105 over 10, and that's going to be about C, should equal sine of B over 6. Okay, if we cross multiply and solve, we're going to get angle B is going to equal 35.42. Okay, and they already told us angle A, that was angle C, pardon me. Angle C was a given, and that's 105 degrees. And then angle A would be, if you take 180 minus both those two angles, you're going to angle A to be 39.58 degrees. 39.58 degrees. If you do the law of sines to find the missing side, side A, you're going to do sine of 105 over 10 should equal the sine of A, and A is 39.58 over side A, cross multiply and solve, and the measure of the length of side A is going to give us 6.60. Okay. So you've got all three angles solved. They gave us 2 of 3 sides, and so we just had to find the missing third side, which is 6.60. So I solved it. Now, if you're wondering, could there be a secondary triangle? You could take the measure of side B, okay, and you do 180 minus it and see if you could make it to work, but it's not going to work, so let's go with it. If you have angle C, which was given, is 105. And we found, the first angle we found was angle B. Okay, so angle B. So if we want to find angle B2, we're going to take 180 minus B1. B1 is going to be 35.42. So if you do 180 minus it, you're going to get 144.58. Now look at this. Is that possible? No. Why? Because C is 105. And if you have 105 with a 144, there's no way you can have a third angle in that triangle. It's not even going to be a triangle. Those two angles together are bigger than 180. So there really is going to be only one triangle that can be formed if you have an angle side, and it's a given angle is going to be obtuse. Okay, so just solve the triangle that happens if there is one there. Okay, so let's keep trucking. And let's look at this next problem. Again, I know 2 sides and an angle. Because there's an angle A and a side A across from it, we are going to say there is a pairing. And so let's draw it. So they give us angle A is 39 degrees, and they give us side A is 14. They give us side C, okay, we'll place it between these. Side C is 20, and then angle C will be across from it, and this would be B, and side B across from it. Now look at this. If you look at this, you'll notice that, and if I try to draw it a little bit better to scale, okay, you'll notice that this first side is 20. And so this side right here, okay, the side below here, I should make it a little bit less steep. Can't draw at the bust, but you'll notice that the 14 is short enough to probably fit inside and outside of this triangle. Okay, there's 2 positions that second one will fit. Okay, it's kind of like you get a puppy, you can bring it outside and inside. So if this A side was actually like 30, longer than that 20, it would have to stay outside this figure. Okay, it just have to stay outside. Like if you got a pet elephant at the fair. Okay, so the 14 is shorter than the 20, so it can probably have the 2 positions to form 2 different triangles with that given value. And so let's practice solving this triangle. Okay, the 2 triangles that will be formed. And so our first step is we know a pairing, so we're going to start with side A and angle A. So we're going to do sine of 39 goes with 14 and set that equal to the sine of C, over 20. Cross multiply and solve, and you're going to get angle C is equal to So turn my page. Angle C is going to be equal to 64.03 degrees. Now, we already know that angle A is equal to 39 degrees. And we can find angle B in a second. Okay, that's going to be the side angle is not. But before we do that, let's talk about, is there a secondary triangle that can be formed? Okay. And we'll subtract those two angles and get the measure of angle B in a smidge, okay? And we'll solve and find the length of B, okay? And some people like to finish that. But before we get there, let's think about, can you take the given angle of 39 degrees, the side that's 20 and the side that's going to be 14, and draw this same dimensions in a slightly more narrow fashion? So we're going to swing this in and say, okay, if this is 14 here and this is 14 here, we know we found this angle to be 64.03. And because it's an isosceles like triangle here on the right, we're going to say, well, then that means the two bases have to be 64.03. And then if we want to find the look of this more narrow option for angle side, we find the supplement, okay, of 180 degrees minus 64.03 to find this angle right here, to find this more narrow option for this being the angle, the side, and the side together. And so we're going to do, to find angle C2, we're going to take 180 minus C1. Okay, and so this first angle that we found, and so 180 minus 64.03, angle C2 should equal the supplement of 64.03, which is going to give us 115.97. Okay, so we've got C2. They gave us A, so A has to stay the same. So angle A is still 39 degrees. And then the sum of these subtracted from 180 is going to give us angle B. Number 2 is going to be 180 minus 39 and 115 is going to give us 25.03. Okay, and we've got to find the little bottom piece of that more narrow triangle. So we're going to do the law of sines. We're going to do sine of 39, which is going to be A, goes with side A, which is 14. And then we're going to do the sine of B2, which is going to be 25.03. And then over B2, cross multiply and solve, and you're going to get this more narrow triangle to have a lower side of B number 2 to be 9.41. And so we've solved the more narrow triangle. We just have to go back and be like, okay, that larger triangle, 180 minus the given A and the bigger C is going to give us angle B to be 76.97. And then if you want to find the overall bottom to this larger option for angle side, you're going to do sine of 39 over 14 is equal to the sine of side B, angle B, which is 76.97. That's B over the lower bottom, cross multiply and solve. And that of the bigger triangle, the bottom side will equal 21.67. So the deal is, if you have angle side, if that second side is shorter than that middle side that you have, you're going to be able to arrange that second side in an outward fashion, which makes a bigger triangle, or an inward fashion that makes a smaller triangle, and you actually have to solve both. And so the way you can figure out if it works is to find that first angle, which is 64.03, and if you find the supplement of it, okay, and then say, with the given A, with that secondary value for that angle, is there enough degrees to form a smaller triangle there? And the answer is yes in this case. And then you'll find the lower value. On the larger value or the larger triangle, you have to finish solving that as well. So it's kind of a lot of steps, and we're going to have to go over it tomorrow in class, but it's a pretty cool situation. Be like, given these values, you can solve the two options for this triangle. Let's look at the last one. If you are given an angle A to be 73 degrees and you see the side 12 to be 12, okay? And then this is A. And then over here, they give you side B to be 17. We can do the law of sines, okay, to help us find this answer. And we do sine of 73 goes with 12. That's A. Check to see sine of B goes with 17. Cross multiply and solve, and you're going to get an error. Okay, so that means there's no triangle. That means that 12 is not quite long enough. Okay. Now, my question is, if it was just a little bit bigger, probably could make two triangles. Like if A actually was like a 13 or 14, you could probably form a wider triangle or a more narrow triangle with those dimensions. And you would find the measure of B, you would find the supplement of angle B, and then you would solve both triangles to find a more narrow and a more wide version of those triangles. If the value of A was, say, like 30, well, then the 30 would have to stay outside. There'd only be one triangle you could form with it. So if this is going to be the one that if it's too big, it's got to stay outside and it can't swing in both ways. If, however, it's a little bit longer than this middle side right here, you probably can make two triangles out of it. Okay. This one happens to be too short, so you can have no triangle. So I think the other important thing would be, if you have angle side side, which means you've got two sides in an angle, and how you know that it's angle side side, not side angle side, is if you have a pairing up of two sides and one that has a match. So if you know side B and you know side C, but you know angle A, no, that's not angle side side, that's side angle side. And so you've got to watch to see what you know. All right, thank you. Have a good day.